Have you got some ideas? Did you notice that if you picked out two different colours, then you were able to find a way to cover the rest of the board with dominoes? But every time you picked out two of the same colour, you were left with two of the other colour left over.
Two black.
Two blacks left over. So why is that always going to be the case?
Okay. One domino covers a white and a black. You can't cover a black and a black or a white and a black.
Exactly.
Take any domino, put it down, and it's going to cover exactly one black and one white square. If we remove two black squares at the beginning, every time we put a domino down, we get rid of another black and another white, and we're going to be left with two white squares at the very end. So there's no way we can cover the board. Isn't that amazing? One simple idea, the fact that we cover a black and a white every time we put a domino down, allows us to count them off at the same time. If we remove two black squares at the beginning, every time we put a domino down, we get rid of another black and another white, and we're going to be left with two white squares at the very end. So there's no way we can cover the board. Isn't that cool? Alright, what if we remove one of each colour? How do we check that we can make it all work? Now, just because there's not an obvious reason that we can't do it, doesn't mean we can. I mean, if I'm a human, I have a brain, is not the same as saying, if I have a brain, I am a human. I could be a little birdie. So we could do this in a case-by-case basis. We could now say, well, not if we do the two side-by-side. What if we did the one there and then three over, and that's long, and that's tedious, and it's not really the way mathematical explorers like to understand the things. It's kind of like knowing that if you take a step forward here, and then you take a step there, and then you take a step there, and you take a step there, and you take a step there, that eventually you'll get from here to there. But another way is to sort of be able to look out across the whole thing and say, yeah, if I go in that direction roughly, I'm going to get there. Alright, here's the big picture way of seeing it. Have a look at this chessboard, and now look at these little ropes that I've put on it. Imagine you can't put a domino that crosses any of those ropes. Now you get rid of any two squares, as long as one's black and one's white. Alright, just like this for instance. Now let's start by putting a domino right next to that first one, and then continuing around, and we're going to get there all the way around to that next one, and we'll come just up to it. And then we can leapfrog over it and do the same thing on the other side. And lo and behold, we're going to cover the whole board. And there was nothing special about which two I took away. There was something pretty special about these beautiful placement of ropes that I've got on there, but there was nothing special about the rest of it. Well, that's all good and well, but that was kind of hard, and that took a great piece of insight that I didn't have. Somebody else showed me that. But it's a beautiful piece. And you know what? You might have stumbled on that if you did the case-by-case basis. That's kind of probably how they found it in the first place. But what has all this got to do with monsters and umbrellas and Königsberg?